In this video, we will talk about functions in R. Now, we have already been using functions in previous videos, but in this one, we will cover in detail what functions are and how we can use them effectively. So, what are functions? Functions are named objects in R that can receive input and return output. They can be found within software packages or libraries that come pre-installed with R, often known as base R, or in packages that you can download and install from the web or other sources. You can think of functions as tools in a toolbox or equipment in a workshop. The function being the individual tool or equipment, and the software package being the toolbox. Let's say I want to make orange juice. Well, I could use an orange squeezer, a juicer, or let's say a blender. The input would be oranges, but the output could be orange juice, it could be a smoothie, depending on what tool I use or what function I use. There are a huge variety of functions across multiple software packages in the R ecosystem. So if you have installed a particular package and you are interested in the function and want to find out more, you can look up details about it by adding a question mark before the function name and entering it in the console. For example, we have plotting functions. Recall that right at the beginning of this course, this was the very first function we used to plot a dataset called cars. Now remember that in R, functions always have rounded brackets right after the function name, and within these round brackets, we put the inputs. If there are multiple inputs, they are always separated by commas. Remember that in the past coding exercises, we have this data frame called team details. And if we extract this column called perform using the $sign, we put it as an input to this function, and this plot function would create a chart or create a plot. So in this case, we can see that there's one person with low performance, two people with medium performance, two people with high performance. There are also a wide variety of statistical functions that come pre-installed with base R. For example, we can find the mean age of people in team details using this function called mean, and that would find the average age of 30. We can extract the number of rows of a data frame as well. You may refer to your notes for a longer list of basic functions in R. Now, other than using functions that can be found within R packages, we can also define our own custom function. This is very useful if we have many long lines of code which we want to run multiple times, and we do not want to repeat ourselves again and again. Instead, we can put these lines of code into a function. Using functions thus provide us a way to make our code much more concise and easier to read. Here's the general structure for the code required to define a custom function. So first of all, when we want to create a function, we have to use the function. And of course, as per usual, use rounded brackets. You would have to define the inputs that you expect this function to receive. Next, you would open up a squiggly bracket and enter in your calculations, whatever they may be. Note that the opening and closing of the squiggly brackets can span across multiple lines of code. Finally, you would also define your output for this particular function. So all your calculations are done within these squiggly brackets. Of course, we will want to assign this function to a particular name, and in subsequent calls to the function, you use the function name, whatever that may be, and within the rounded brackets, you have your inputs, whatever you have defined here. Of course, if you have multiple inputs, they will be separated by commas. Let's run through an example using the grades dataset that can be found within the data folder. So this dataset contains the grades for an individual for multiple subjects. So most importantly, we have the grade point, which corresponds to the letter grade, and the credits for each subject. Let's say we assign it to the object name grades, and let's say we want to calculate our GPA in R using this formula. For each subject, we will have to calculate the grade points multiplied by the credits and sum this up across all the subjects, and then divide that by the total number of credits across all subjects. this would be the line of code. So this is a numeric vector of grade points multiplied by a numeric vector of credits. That would return a vector. And we would sum up all values within that vector divided by the sum of the vector of credits. So for this person, his GPA would be 3.42. Now, let's create a function that will calculate the GPA for a student based on that formula. It would take a data frame as an input, and specifically, we are interested in two columns, grade point and the credits for a particular subject. And we want to output a single value. So here, we create a function, and in this case, we can define the input name as x. It is important to refer to the named input within your function. So for this data frame x, we're interested in the grade point multiplied by credits, same formula. Remember that operations in R are vectorized, so this is a vectorized multiplication. So the first subject's grade point will be multiplied by the first subject's credit, the second subject's grade point will be multiplied by the second subject's credit, and so on. Notice that for this function, we directly return the output of this particular line of code. So instead of manually writing out the entire formula, we can use the function scorer and put in the data frame grades as an input. Now, what if you have a whole cohort of students and you need to calculate the GPA for every single one of them? This is when loops might come in handy. Loops are a special type of function that allow you to repeat code for a specified number of times or number of iterations. The most common type of loop is called a for loop. Let's continue with our example. Let's say we have the grades for the other 4 team members in separate files. We can import them individually and combine them into a list named team grades. So we have 5 elements in this list, each containing a data frame of grades for a student in the class. Here is how a for loop looks like in R. Notice that it follows the same general structure as a function. First, you have the name of the function, in this case the for loop, followed by the rounded brackets with inputs, and the calculations are done within the squiggly brackets. In this example, we want to calculate the GPA based on every item or every data frame in the list team grades. And so for every single one of these data frames, we want to use the function scorer to calculate the GPA. So we would output a single numeric value for each item of this list. What we want to do is to append this value to a new column called GPA in team details. Recall that team details is a data frame containing the details for 5 members of the team. Notice that within the rounded brackets of this for loop function, it looks a bit different. Firstly, you see an index or object called I, and you see a sequence of numbers 1 through to the length of team grades. So in this case, rather than using a single number, I used a dynamic variable. The length of team grades in this case is 5, because we have 5 data frames in this list. And so this would output a sequence of numbers 1, 2, 3, 4, 5. This means that there are 5 iterations in this loop. The value of I would change during each iteration. So in the first iteration, the value of I would be 1. In the second iteration, the value would be 2, and so on. So we have our list team grades, and notice that we are doing subsetting over here. So let's say in the first iteration, when the value of I is 1, we will be subsetting the first element of this list, so the first data frame. This first data frame will be an input to the function scorer, and that will return an output value for the GPA. For every iteration of this loop, the output of scorer would change because the input would change. For every single one of these outputs, we want to assign it to that new column. How do we do that? Well, notice that we have defined a new column called GPA using the $sign, and this new column will be in team details. Here we use subsetting again, but in this case, this is a vector, a numeric vector. Here, we subset this new column based on the corresponding index value from team grades. This means that for every iteration of this loop, the GPA column will be populated one by one for numbers 1 through 5. After running this loop, now we have a new column called GPA, and you'll notice that Harry has the highest GPA amongst these 5 students. If you didn't quite catch the code for loops, don't worry, we'll be going through this in detail during the hands-on portion of this video. Finally, I'd like to highlight that R comes with some built-in loop functions such as lapply or listapply and apply. This allows you to apply functions to objects in R depending on the data structure that is supplied. For example, if you want to apply a function to tabular two-dimensional data, you can apply it across the margin of rows or columns. For instance, recall that we have our data frame of team details. In columns 2 and 5, we have numeric variables for age and the GPA. So, if we subset this data frame to only these 2 numeric columns, we can apply the mean function across the columns of this data frame. This would give us the average age and average GPA. Here's another example. Recall that we have the built-in dataset empty cars, and all of these columns are numeric columns. So we can simply supply this entire data frame and apply this function mean across the margin of columns. This would give us the average value for every single one of these variables. Let's demonstrate some of the concepts that we've covered during the lecture. This is the notebook that we've been using in past lectures, and notice that we have already been using functions as part of our previous exercises. Let's try to look up this data function. Recall that you put a question mark before the function name. Notice that the help tab will be highlighted. This is the function name, and it can be found within the software package utils that comes pre-installed with base R. Here, you'll find helpful documentation about what this function does, what are the various types of arguments or inputs that can be supplied, and the expected format for each of these arguments. There's also usually a section on more details, the expected output of the function, and very importantly, some examples that you can refer to on how the function may be used. Now, let's try to create that custom function scorer that we talked about during the lectures. Let's create a new code chunk. Let's load in the dataset grades, read.csv, and this will be the formula to calculate the GPA for this data frame grades. The output is 3.42. Now let's wrap this code in a function. That's the name of our function. Type function. Instead of X, we can even say that you want the input to be a data frame. Note that since we have defined the input as data frame, this object name will need to change. Another thing to note is that in R, code indentation is important for readability. Indents are not crucial for the code to run, but they help indicate that this line of code is within the squiggly brackets. Let's now create this function. Notice that now there's this new header called functions, and we have the name of our function there. We can run this function for grades, and we will get 3.42 as well. Next, let's input all these CSV files for the 4 other members of the team, and let's combine them with that first data frame into a list. And now we have team grades, which is a list of 5 elements. Let's now demonstrate how to create a for loop. We will use the for loop function. In R, it is common practice to use the letter I to represent the index or iteration number within a loop. You don't necessarily have to use this object name, but you'll see this most commonly used online and in other tutorials. So for I in, we can simply write the sequence of 1 to 5. Let's say we want to print out the value of I during each iteration of this loop. We can run this code, and you'll notice that for each iteration, the value of I is printed out, and this loop was run 5 times. Now we're interested in running the function scorer for this list called team grades. And we want to run this one element at a time. So we use the letter I to index or subset this list. Let's say we store it in this temporary object called output. And let's say we print the output. So if we run this code, for each iteration of the loop, the GPA value is calculated for the corresponding element in team grades. Also, notice now that there's this new object in your environment called I, and it is the integer value of 5. During each iteration of the loop, the value of I changes and the value is overwritten, and the very last value of I would be 5, as shown here. And so this value would be the one remaining in your environment. Now, instead of storing each GPA value in this named object, let's assign it to a new column called GPA in team details. Notice that if I highlight this section of code and I run it, it indicates null, meaning that there's no such column in team details now. We will assign each GPA value to the corresponding index value of this new column. And let's remove this. Before running this loop, we do not have the GPA column. And after running this loop, in team details, now we have the GPA column. Finally, to demonstrate some built-in loop functions in R, let's say we take the numeric columns in team details. This would be H and GPA, columns 2 and 5. Let's say we use the apply function, and we want to apply across the columns and find the mean value of H and GPA. So we get a mean age of 30 and a mean GPA of 4.16. Finally, our last example, we can load in the dataset empty cars, and now we have that in our environment. We can use the same function apply, and this time all the columns in empty cars are numeric, so we can run this. We get the average value for each of the columns in this dataset. All right, we've come to the end of this video on functions. This was quite a heavy topic. I hope that this demonstration has helped solidify your understanding of functions. In the last part of this section, I will introduce the tidyverse, which is a collection of packages that help with data manipulation and visualization. I'll see you in the next video.